Hey guys, welcome back to my YouTube channel. In this video, we'll be continuing our video on uh, pa- uh percentage error. So, in our last video, we introduced the formula and solve some questions. You can do it to check it out if you haven't checked it out. So, in this one, we'll be looking at percentage error that has to do with place values. That is, decimal places, units, tenths, or value. So, we can calculate and also look for ranges of percentage error. So the actual thing is that no measurement, however, if you look at it carefully, can exactly be accurate. If you have a length of like a place now, for example, of a classroom, and that is measured in that is actually measured like let's say 2.8 meter. You measured and you got 2.8 meter, and the truth of the matter is that it can be maybe actually measured in two uh it was measured to two significant figure, but it could have been from 2.75 to 2.8 2.75 2.85, because between this could have been between this. So if you have approximated this, you can get this, and if you approximate to 2.84, you could have gotten 2.8. So it could have actually been of this. So now to calculate for this error, the error of this measurement, that is in terms of like of this error, this would be like a unit of that will be an error of like a one decimal place, that's a tenth. We are measuring like you are taking the unit of the tenth. So taking the unit of the error of tenth of 2.8 millimeter. So what you have to do, we already have the range. This is like the possible range. Then to get the error, you can just take any of this or some any of that and just find the absolute like we did in our last video. That'll be 2.75 minus 2.8. Then when you find this, then your answer will be 0.5. Sorry, 0.05. What I like to do is, since is one decimal place, I'll just 2.8 place a 1 behind the position, then just 0, or place a 1 behind the no place a 1 behind the position, then put the wherever your 0 is, that's 0.1, then just divide it by 2, you get 0.05. That's the trick I do. So but like you can also go with this, so you have to divide this all through, sorry, minus it, then you use the percentage error like we explained in the last video. That will be percentage error is equals to error. Now then you have the error over the true value times 100. Our true value here is our actual measurement here, so that will be 0.05 over 2.8 times 100, which is equals 1.785%, which cancels 1.79%. So this is that about that. So let's say for example now, like suppose the length of the same room like is to be measured, but like no, we did it to the nearest one decimal place now in this regard. So what, let's do it to the nearest uh suppose the length of the same room is measured to the nearest centimeter, in this regards to the nearest centimeter. So uh we have, and which our previous this thing was, if it converted to centimeter, this 2.8 meter now converted to centimeter, that will give us 2 centimeter, right? And we should calculate the percentage error. So when I want to calculate percentage error, so the measurement is 2 centimeter, and the range, now to get the range now we need like the possible the error, like the error, and the possible error, how I calculate it, since they say to the nearest centimeter. So in if you are calculating 1 centimeter is just 1 centimeter, right? So I divide by 2 and I get 0.5, right? So now to get the what's the no the range, yeah, the range, you add and subtract this too. This is to give us the error, by the way. That's plus and minus of our error. So that will be from 2, yeah, 2 279.5 to 28.5. And now just to show that we have the error, then you can now calculate it based on, this isn't like a formal way of solving getting your error. This is not a formal way. This is where I get mine. So you can just subtract 280 minus any of them. That's like the absolute. Let's say 279.5. There's no absolute. So our answer will be, like we've already done it for 0.5. Then we can use this now formula now. Our constant error is equals to 0.5 over the true. Sorry, the true value is 280 times 100. That'll be 0.178 percent. So we can estimate it to 1. So we have that about that.